Alright everyone, welcome back to the day 27 of our daily leetcode challenge, and today we have got course schedule 4. Now let's try to understand the problem. What they have provided us with is a num course value which indicates the number of courses that we have, and a prerequisite list wherein it indicates that the course A is a prerequisite for course B. So in the terms of graph, this is a graph problem where these num courses are nothing but the number of nodes in the graph, and these prerequisite list that you see is nothing but an indication between nodes A and B, which means that node A is connected to node B. So for example, in the third example, if you see, the num courses is 3, meaning we have 3 nodes, and if the value of n is 3, which is the number of nodes in the graph, its values start from 0 all the way to n minus 1, meaning if the n value is 3, we're going to have nodes as 0, 1, 2. If the value of n is 9, you're going to have nodes as 0, 1, 2 all the way till 8. So this is what the value of n is, and that's how we are getting the nodes. And if you take a look at the prerequisite list that they have provided, it indicates that there is a connection from node 1 to node 2. If you take a look at the third example, the number of courses is 3. So the nodes we have are 0, 1, 2, and the prerequisite list that they have provided indicates a connection. So there is a connection between 1 and 2, as you can see here. There is a connection between 1 and 2. There is a connection between 1 and 0. There is a connection between 2 to 0 as well. So this is how the problem has been described. This is nothing but a directed graph where the number of courses is the number of nodes, and the prerequisite is indicating that the vertices 1 and 2, or the nodes 1 and 2, are connected to each other. So this is how the problem has been defined. What they want us to do is that they have provided us with a list called queries, and they want us to determine if there is a connection between 1 to 0, both. Either it could be a direct connection or an indirect connection. So let's understand what they mean by the indirect correction or the direct correction. So let's take a look at the first value at the queries list that they provided. They want us to know if the vertices or the nodes 1 and 0 are connected or not. So that's why if you see, the answer is a Boolean answer. So the length of this answer list is going to be equal to the length of the queries list, because for each query they want us to know if there is a connection between these two nodes in each query that they have provided. So if you take a look at the third example, you see the nodes 1 and 0 are connected with each other. That's why we return a true. And the nodes 1 and 2 are connected with each other. That's why we return true again. Now these connections that you see here between 1 and 0 and 1 and 2, both of these are direct connections. So it was easier for us to determine that, alright, we already have a connection here, so we return true. But this is the case of directed connection. But what in the case if there is an indirect connection? So what I mean by that is, let's take a look at this bigger example that we have drawn here. If you see, the nodes 0 and 1 are connected with each other, the nodes 1 and 5 are connected with each other, the nodes 4 and 5 are connected with each other. These are all the direct connections that we see, which have been drawn here. But if you take a look at the indirect connections, you see that the nodes 0 and 5 as well are connected with each other via node 1. And another example of indirect connection would be the nodes 0 and 4 are connected with each other via node 3. If you see, we can travel from 0 to 3 as 1, and then in the other way we can go from 3 to 4. So this is how nodes 0 and 4 are connected with each other via node 3. So what I mean by that is, in the case of the queries list that they have provided, if they provided us with a query as in 0, 4, meaning they want us to see if the nodes 0 and 4 are connected with each other. If we directly look at the prerequisite right now, the prerequisite will only provide us with the direct connections that we have. In the case of 0 and 4, it will only provide us with like 0 is connected to 3, we know that, and 3 is connected to 4. But if there would have been a way for us to know that the 0 and 4 are also connected with each other, in that case we could have returned true for this as well. If right now we just use the prerequisite that we have, we would return false for this one, meaning there is no direct connection between 0 and 4. But we need to find all the connections, either direct or indirect. So what I mean by that is, we need to somehow find a way in which we can determine if any two nodes in the given graph, any two nodes are connected with each other, either one via a direct connection or two via an indirect connection. So this is where we are going to use the famous algorithm called Floyd-Warshall algorithm, and what this algorithm does is basically helps us to find the minimum distance between any two nodes in a graph, but it also helps us to find if two nodes are connected with each other either directly or indirectly, which would be helpful in our case that they have provided us. Basically, if you take a look at the example there, they have also mentioned that prerequisite can also be indirect. which I just kind of explained it to you. This is a prerequisite or a query which indicates that alright, they are looking for a indirect connection. So this is what they want us to determine, that you need to determine if two nodes are connected either directly or indirectly. You tell me that, like they could have also asked for nodes 0 and 5. Now nodes 0 and 5 are not connected directly, but they are connected indirectly via node 1 right here. Or you could also take this path right here, 0 to 1, 1 to 4, and then again 4 to 5. Or there are another path called 0 to 3, 3 to 4, and 4 to 5. So these are all the possible paths that they have. The Floyd-Warshall algorithm will always determine the path with the minimum distance. So that's one implementation of the algorithm, and the other implementation is it also helps us to tell if two nodes are connected with each other via directly or indirectly. So we're going to use the second kind of use case of the algorithm to determine if two nodes in this queries list are connected with each other or not via directly or indirectly. So now let's try to understand how we can implement that algorithm, that the Floyd-Warshall algorithm in our use case here. So let's try to understand how the algorithm is going to work. So first what we need to do is we're going to have to define a matrix which is going to be a n cross n matrix, meaning it's going to have n rows, n columns, and that n value is nothing but the number of nodes that we have. So if you take a look at this example, this bigger example is going to help us understand the other examples as well. Here n value is 6, meaning they are nodes from 0 all the way to 5. Now if we try to convert this to a matrix, we're going to have 6 rows and 6 columns. We're going to have 6 rows and 6 columns. Initially we're going to let me draw that matrix first. We have 0, 1, 2, 3, 4 and 5. Have 6 rows and 6 columns. Initially what this basically means is, do we have a connection from the I and j values? So this is what we have initially. We're going to set all these values to false, meaning there is no connection from node 0 to 0, there is no connection from node 0 to 1, there is no connection from node 0 to 2, there is no connection from node 0 to 3. Initially this will be a matrix full of false values all the way from 0, 0 to n minus 1, n minus 1. All these values will be false initially. This is how we're going to start with. So all these values are going to be false everywhere in all rows and columns. All these values are going to be false. Now what we're going to do is we're going to take a look at the prerequisite that they provided, and we are going to build connections. By building connections, we're going to, what I mean by that is we're going to change these values from false to true. So if you take a look at the queries, by these values that we have here, let's take a look for node by node. So we have the node 0, it has a connection of node 1, 0 to 1 there is a connection. So node 0 till to 1, let's put this to a true. So this becomes true. 0 to 1 is the connection, true. From 0 to 2 we have a connection, so let's put that to true as well. 0 to 2. This is how we are going to iterate. This I row and j column basically means there is a connection from the 0th value at this row and the jth column that we have, whatever column that we are going to go with. So this true value basically means that there is a connection between the node I to j, and here I and j values are nothing but the rows and column values all the way from 0, 1, 2, 3, 4, 5. This also ranging from 0 to 5 inclusive. So this is how we are setting this true basically indicates there is a connection from this ith row to jth column, or you can say that node at I and to the node at j, the value. So and now there is also connection between 0 to 3, so this value becomes true. Now what else? Now so 0 is done. Now let's come to 1. 1 is connected to 4 and 1 is connected to 5. We are only going to draw direct connections right now. This indirect connections is where the algorithm is going to take place, but let's draw all the direct connections. So if you take a look at the node 1 is connected to 4 and 5. So 1 is connected to node 4 right here, this becomes true, and node 5 right here, this becomes true. Now let's take a look at the node 2. Node 2 is connected to 3 and only 3 at the moment, so let's put this value right here to true. Then comes to then comes node 3. Node 3 is connected to node 1 and node 4. Node 3 is connected to node 1 right here, and node 4 right here. So these two values become true. And then we have node 4 which is connected to node 5 at the moment. So node 4 is connected to node 5, which is the last index right here. This becomes true. And then node 5 is connected to nothing at the moment, so all these values are false. Now what we need to do is we need to find if, now these are everywhere where we have a true is nothing but the direct connections. These are all direct connections, meaning we have a direct connection between node 0 and 1. We have a direct connection between node 0 and node 3. We have a direct connection between node 2 and node 3, as you can see. So this is what the true value initially indicates. We started with the matrix which was false everywhere, then using the prerequisite that they provided, we updated these values. Now if you see, now we need to find where and all we can see some kind of kind of like indirect connections. So if you see, node 3 is connected to node 4 right here, and node 4 is also connected to node 5. We saw that as well. So if you see, this is how we're gonna start doing the indirect connections now. Now to find using the for the indirect connections, how many nodes we have? We have a total of 6 nodes from 0 all the way to 5. Now for each intermediate node that we have, each intermediate node 0, 1, 2, 3 all the way till 5, we're gonna see if we can find a connection between any two given nodes via this intermediate node that we have. So what I mean by that is, do we have like all the possible connections that we can form right here, which is n cross n, all the possible connections that we have, in all those connections, do we have an intermediate connection via 0 or not? So this can be done. We can take this node 0 and then check if there is a connection between node n to 0 and then again from 0 to n. This has to be true. Both of these connections need to be true. If this is true, this would mean that we have an intermediate connection between node. We can go from this node, any two nodes we can go via this node right here. If this is like, let's say we have a node, any intermediate, let's take the example of node 1 right here. This node 1, we're gonna try to find if there is a connection between node 2 and node 4 via node 1. What would that mean is, we're gonna 100% need a connection between 2 and 1. That should be true in this matrix. 2 and 1 should be connected, and then again 2 and 4, the other side of the, let's say we want to try to find between 2 and 4. 2 and 4 we are trying to see if there's a connection. So 2 via 1. So there should be a connection between 2 and 1, and then there should also be a connection between 1 and 4. So both these values should be true. So this should be an AND condition. This has to be an AND condition here. Both should be true, and if that is true, that would mean that we have an indirect connection via for 2 and 4 via 1 as well. So if you take a look at this example, let's try to find all those indirect connections that we had. So if you take a look at this thing right here, 3 and 4 and 4 and 5. So if you look at the matrix, 3 and 4 are connected with each other via this. 3 and 4 are connected, and then again 4 and 5 are also connected. 4 and 5 are also connected. So this means that via node 4 we can reach 5. So like this is what I'm trying to say. 3 and 5 via 4 is going to be a connection between 3 and 4, and then again for the 4 and 5. So this is how the via thing works. You can reach this node 3 and 5 via 4. So both these values should be true in the matrix. If this becomes true, then we can say that we can reach 3 to 5 via 4. So this is how the kind of the indirect connections are going to work. So we're going to have to iterate for all the values all the way from 0 till 5, all these values from 0 to 5, and then we're going to make a check. We're going to make a check if we can go for each of these pairs that will be forming. This will be n cross n. Each of these pairs that will be forming for each of the nodes from n, for each of these pairings n cross n, there is a connection. Meaning, let's say we take node 0 and we have nodes 3 and 5. Is there a connection from 3 to 0 and then again from 0 to 5? This is how the indirect connections will also be set to true in this matrix. So if we do that, the time complexity will become n cube, where n is nothing but the number of matrices, number of vertices, the number of nodes that we have. And once we have that, this would be the time point. Once we have that, the directed as well as the indirect connections set in this matrix as true. Once we have that, then we can simply iterate on the prerequisite on the queries list and then return using the values from. So what we'll be having is, do we have a value from 0 to 1, meaning 0th row and first column as true or not. So this could be indirect as well. 3 and 4 could not be connected directly. 3 and 4 could not be connected directly. Let's take a look at this example. If I erase this connection, 0 and 3 would not be connected directly in this matrix. It would be a false initially once we draw this. But using this adjacency thing for node, when we'll be taking an example of node 2, and when 0 and 3 comes, we'll see that 0 and 2 is connected with each other, and 2 is 3 is connected with each other. So these two values are true, but this is false in the case of node 2. This is false, right? But once we have at node 2 and we want to do that comparison, we'll see that this will again eventually turn to a true, meaning if in the further down in the queries list they have a connection, they have a query as in 0, 3, initially would have been returning false, as it would have been false in the matrix, but it would get updated to true because of this 2 node right here. Since we have a direct connection between 1 and 2, 0 and 2, and a direct connection between 2 and 3, this will eventually become from a false, this will eventually turn to a true using this AND operation that we are doing. So if I code this up, you will kind of understand this better. Alright, so let's start to code this up now. So what I really first need is a matrix where all the values are false, and this will be a n cross n matrix, n as in the number of courses. And to make that quickly, we can define this variable called matrix. Initially all its values will be false. So this right here gives us a matrix which has all the values as false. For n cross n. So if you take a look at this example, we have a standard matrix of 3 cross 3. Here the number of forces is 3, so a 3 cross 3 matrix, all the values set as false, as we drawed in the example, all the values set as false. Now what we'll do is we'll go through the prerequisite that we have, I and j, and set those values to true, meaning there is a connection from the ith node to the jth node. I here is the row and j here is the column. So to do that, we can quickly iterate the prerequisite list that they have provided us. Matrix I comma j will turn to a true. We updated it. So this is the direct part. Now what we need to do is, for each intermediate node all the way from 0 to n, we need to check if there is a indirect connection or not. So far we have only drawn the direct connection as true. Now we need to check for the indirect connection. So meaning for each intermediate node 0, let's say 0 in the case of, or 1 we can take, or any other node 0, 1 all the way till n, is there a connection from between any two nodes in the matrix that they provided via this node. So basically n and n cross n, all the pairings that we have, n cross n, these are direct pairings. Is there a connection via any of these from 0 to n, n minus 1, any of these nodes via this node to all these nodes that we have a connection or not. So for that, we need to check if we have a connection between nodes I and j via k. So how will we define that? So we have this matrix I and j, and we need to check if we have a connection between I and j via k. So what that will look like is, initially whatever this value is, I comma j, this will get updated, right? So we'll have to do this OR along with this AND that we were talking about. This is where the AND comes in. So if both these values are true, meaning we have a connection between I and k and a connection between k and j. If both these values are true, this would mean that the node I and j are also connected. If they are connected initially, if this value is true, then there is no point checking if there is a connection via this matrix or not. then we'll leave it as it is via this other intermediate node or not. But if this value is false, meaning we don't have a connection yet, but if we have a connection via, that would mean this value should be updated to 2, as we discussed in this case. Initially, let's say initially 0 and 3 was false, right? 0 and 3 was false, but since we saw that we had a connection between 0 via this intermediate node 2, this intermediate node 2 gave a connection between 0 and 3. How? Because 0 and 2 was connected and 2 and 3 was connected. Since this 0 and 3 nodes initially set to false, initially let's say I and j is 0 and 3. 0 and 3 initially this value is set to false, but for an intermediate node 2 we saw that 0 and 3 is connected. How? Because 0 and 2 is connected, as we saw in this case 0 and 2 is connected and 2 and 3 is also connected. So that is why we are taking an AND connection. Both these connections need to be connected via k. So I has to be connected by k and k has to be connected by j. Only then we can say that I has been connected to j. That is why we are doing a OR operation here, because this value has to be true, and once this is true, no matter if this is true or false, if it's false, it means we have an indirect connection between I and j. Initially it was not directly connected, but now we have an indirect connection because of a intermediate node k. This is how we are updating the matrix. What I was trying to explain now is now becoming clearer with this code. So this is where the n cube is also coming. We are going via the nodes 3 times. So this is all the initial pairings, n square, and this is pairing them with an intermediate node. So now once we have this is nothing but the updated matrix. All these values updated. Now all we have to do is go through this queries list, so and return whatever value that we have in the matrix. I comma j for I comma j in queries. This query is right here. This matrix is updated, including the direct and the indirect as well. This will have true in cases of indirect connections as well. So we'll have the correct answer now. So if we run this, you can see satisfying all the test cases, both direct and indirect. So this is how the algorithm is working. It's a n cube time complexity and n squared space complexity, because we are working with a matrix of n cross n, and we are looping 3 times for the number of nodes that we have. So this is a n cube time complexity and n square space complexity. So that was it for today, everyone. I'll see you in the next one. Like and subscribe.